Alright, so as you remember in a previous video, I went over the basically the process you can go through to create the unit circle. Alright, so this video is going to be more about how to use the unit circle to find the exact values that your teachers are going to be asking for. So the values that they're going to be asking for, the primary ones they're looking for, are sine, cosine, tangent, cotangent, cosecant, and secant. And the two primary ones that create all the others are sine and cosine. Right? So if you can find these two, after that you no longer need the unit circle, and it's just some simple algebra to find these other four values. So let's go ahead and start with a simple sine problem. So let's do sine of 5 pi over 4. Alright, and as you remember before, we count around. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4. Alright, so this is 5 pi over 4 radians around the unit circle. And the other part that you can hopefully remember from the last video is the coordinates of each value. So if you make a triangle here, okay, and you can get the coordinates. So all of these center values, all of these center points here, the coordinate that they go along with is square root 2 over 2, comma, square root 2 over 2. And the one thing you need to remember is that this quadrant here, this lower left quadrant, both are negative. Both the x and y value are negative. So in this case, sine of 5 pi over 4 is this value here, the y value, this negative square root 2 over 2. Whenever you have sine, whenever somebody's asking you for sine, they're always asking you for the y value of the coordinate. Alright, so if they ask you for just simply sine of pi over 4, and you want to make this triangle over here, this coordinate is also square root 2 over 2, square root 2 over 2. So if you have square root 2 over 2 and square root 2 over 2, you're going to want the y value. And then if we wanted the sine value of pi over 6, right, this is pi over 6 here. Pi over 6 is, so if we have this point here, pi over 6, right? These coordinates here, the x value is root 3 over 2, and the y value is just 1/2. Alright, so if you want the sine of pi over 6, so if you want the sine of this radian here, it's just 1/2. It's that simple. Alright, so let's go ahead and clear this up, and we're going to work on some cosine problems now. Alright, so now say we want, let's go ahead and erase this up here. So say we want the cosine. So now if y is the sine value, x is going to be the cosine value. So if we create this triangle here, alright, and this triangle correlates with the radian value of, this is 1 pi over 6, this is 2 pi over 6, remember we just count around, and if you reduce this, this is also equal to just pi over 3. So your teacher might ask, what is the cosine of pi over 3? Or the cosine of 2 pi over 6? And also you can add 2 pi to this. So if you add 2 pi to this, that would be pi over 3 plus 2 pi. Now if we have 2 pi, we have to make the denominator 3 also, which means we're going to multiply the top and the bottom by 3, so the top is going to be 6 pi. So if we add these two together, we're going to get 7 pi over 3. So this value is also equal to 7 pi over 3. The coordinate value is the same. Pi over 3 itself is not the same. These are just equivalent spaces on your unit circle, and each teacher has their own vocabulary term that they use for that. But just know that these are similar values, that they're going to be similar coordinate values. So let's go ahead and clear this up here. Alright, so now cosine of pi over 3 is, now the coordinate value of here is the x value, this is 1/2, so we're going to have 1/2, and the y value, if one value is 1/2, the other value is always going to be root 3 over 2. Alright, so now the x value in this is 1/2, and cosine always correlates to the x value, and sine always correlates to the y value. So the x value here is 1/2, so the cosine of pi over 3 is just 1/2, and that's your answer, and you're done. so let's go ahead and clear this up. Now let's work on a tangent problem. These are a little bit different because you need to find sine and cosine first. So let's grab a different color real quick. All right, yellow. So tangent is equal to sine over cosine. So sine, the sine of a value divided by the cosine of the value. All right, so let's try this triangle down here. All right, so we have this triangle here. Now this coordinate, it's going by pi over 6. This is one of the outer of the three. This is going to be some value of pi over 6. So we can just count 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi, 8 pi over 6, 9 pi over 6, and this is going to be 10 pi over 6. And again, we want to reduce this. Both of these numbers are divisible by 2, so it's going to be 5 pi over 3. So we're now looking for the tangent of 5 pi over 3. Now the way that we get this is there's no straightforward way. You can't just look at this and say, all right, the tangent value of 5 pi over 3 is this. All right, so what you have to do is find, like I said before, the sine value and the cosine value. So now the sine value here is going to be the y value, so the vertical value. So this right here is root 3 over 2, and this is in the lower right-hand quadrant. So any quadrant that's beneath the x-axis, the y value is going to be negative. All right, and this is on the right side, so this is on the positive side of the x-axis. So this is going to be positive 1/2. So we can set this equal to, so tangent of 5 pi over 3 is going to be equal to sine of 5 pi over 3 divided by the cosine of 5 pi over 3. And the way you can kind of remember this is when you're talking about slope, think all the way back to algebra 1, you're talking about slope, the m value, right? It's always rise over run, rise over run. And the rise is always in the y direction, and the run is always in the x direction. So tangent is always rise over run, sine over cosine, the y value over the x value. This is very important. This is one of those things that you can really easily forget when you're in the middle of a test. So try your best not to forget it. And the easiest way that I've always used is tangent follows the same rule as slope, which is rise over run. All right, so now these values here, sine of 5 pi over 3 is negative root 3 over 2. This is going to be divided by cosine of 5 pi over 3, which is going to be 1/2. And we remember the rule of division. You multiply by the reciprocal. So this is going to be root 3 over 2 times 2 over 1, because we flipped this value here. This is the bottom number. So the 2's cancel out, and your answer is going to be negative root 3. So tangent of 5 pi over 3 is negative square root 3. All right, so what's also cool is, see how this is negative root 3 over 2, and that's what leads to this negative here. So if we go straight up and we go here, and this value is 2 pi over 3, right? Because this is 1 pi over 3, 2 pi over 3. And we draw the triangle here. All right, so the values are exactly the same. This is going to be root 3 over 2, and the x value is going to be 1/2. So it's going to be root 3 over 2 divided by 1/2, except for the negative. This is going to be positive here. This will be positive, and this will be positive. So these are just kind of like simple tricks to kind of remember. But really what you're going for is simply rise over run or sine over cosine. That's the easiest way to find the tangent value. All right, so let's go ahead and clear this up. All right. Let's erase this here. So now the next value that we're going to look at is the cotangent. So the cotangent, let's go ahead and use this same point again here. So we're going to use the same point, which will be 10 pi over 6. So this is, remember, we're counting again, so 1 all the way up to 10. So 10 pi over 6. So let's find the cotangent of 10 pi over 6, which is, this value here is also, remember, this is also equal to 5 pi over 3. But you have to be able to, you have to be used to seeing these different fractional values for the same coordinate. All right, so cotangent, what co means, so this is cotangent, cosecant, and secant. What these values are doing is cotangent is 1, this is equal to 1 over tangent, which is really just happening is cotangent is equal to, remember tangent is sine over cosine, so cotangent is just cosine over sine. This is flipped. This is not the inverse tangent. Inverse tangent is different. We'll go over that later. But this is the cotangent, the flipped value of tangent. So everything else after this is the same. The cosine of 5 pi over 3 and the sine of 5 pi over 3. This fraction goes all the way over. So the cosine of 5 pi over 3 is simply 1/2. And the sine of 5 pi over 3 is negative square root 3 over 2. Right? And again, we multiply by the reciprocal, so this is going to be 2 over negative root 3. Your 2's are going to cancel out, so this is going to be equal to 1 over negative root 3. Now remember, your teachers don't like to have radicals on the bottom. Even though it's the exact same value, we want to clear the radical from the bottom. So what we'll do is negative square root 3, which is the value that we have right here, times square root 3 divided by square root 3. And we're just dividing by the denominator. It's not anything else. We're just multiplying by the denominator. And what happens is square root 3 times square root 3 is just 3. And we're going to have negative square root 3 on top. And that's it. This is the answer for cotangent of 10 pi over 6. Negative root 3 over 3. Alright, so let's go ahead and clear this again. So now we're going to do cosecant. We're going to look for the cosecant. And cosecant is, there isn't really a really simple way to memorize this. This is just one of those things that you're going to have to memorize, because the people that made the unit circle didn't make this easy for you. So we're going to pick a different coordinate here, and a different color. Let's pick a teal. Alright, so now let's use this coordinate here. Let's do 7 pi over 6. This is going to be 7 pi over 6. Alright, so 7 pi over 6, because we're just counting. 7 pi over 6. Alright, so now if we're going to find the cosecant, now the way I remember this is the opposite. So cosine, right? Cosine is just, this thing up here. Cosecant is going to be equal 1 over sine. It's the opposite of, that co sound, right? The co that comes before it. So instead of cosecant, you would normally think that would go with cosine, right? But it's not. It's cosecant goes with 1 over sine. So if we want the cosecant, so let's find the cosecant of 7 pi over 6. And this is pretty simple. What it is 1 over the sine of 7 pi over 6, and 7 pi over 6, the y value over here is 1/2, but now this is in the lower quadrant, so it's going to be negative 1/2, and the x value is this distance here, and that's going to be square root 3 over 2. So when you draw out these triangles, another easy way to remember this, the longer value is going to be square root 3 over 2, shorter value is always 1/2. Alright, and this is on the left side of the y-axis, so this is going to be negative square root 3 over 2. So now, sine of 7 pi over 6 always goes with the y value. Sine always goes with the y value. So this is just going to be equal to 1 over 1/2, negative 1/2. Alright, and again, we just multiply by the reciprocal. This is going to be 1 times negative 2 over 1. Oops, sorry, it's going to be a 1. So 1 times negative 2 over 1, which is going to be negative 2. So the cosecant of 7 pi over 6 is just negative 2. And that's really simple. So now, the last one, let's go ahead and do secant. Let's clear all this. So now secant, if cosecant is 1 over sine, cosecant is going to be 1 over cosine. Alright, so now, let's get a smaller size here. There we go. So secant is just 1 over, is equal to 1 over cosine. So let's find the secant of, now let's do something different, because your teachers are going to try and throw you off here. So now this is going to be 1 pi over 4, 2 pi over 4, 3 pi over 4, 1 pi over 4, 2 pi over 4, this is going to be 2 pi over 4, this is going to be 3 pi over 4, this will be 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, let's keep going here, let's go 9 pi over 4, this is also going to be 9 pi over 4, 10 pi over 4, and let's stop here, let's do 11 pi over 4. So we want the secant of 11 pi over 4. So let's just check that one more time. This is going to be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4, and 11 pi over 4. So 11 pi over 4 is going to be this triangle over here. Right? And notice I'm just drawing over this. I'm not trying to make this really clean. Obviously, you can tell where I'm at because I'm using different colors. But when you're on a test, you don't need to keep your unit circle clean. You just draw a circle, draw some dashes, and you're good to go. So now we're going to have 11 pi over 4. So the secant of 11 pi over 4, sorry, I wrote this wrong. It's going to be secant of 11 pi over 4. So the secant of 11 pi over 4 is going to be equal to 1 over the cosine of 11 pi over 4. And the cosine here is going to be the x value, and the x value here is negative square root 2 over 2. So negative square root 2 over 2. So this is going to be 1 over negative square root 2 over 2. And of course we're going to flip this. So it's going to be 1 times 2 over negative square root 2. Doesn't matter where the negative goes. So 2 over the negative 2 over the square root 2. And again, your teacher doesn't like the radical on the bottom. So we're going to multiply this by square root 2 over square root 2. And we do this because square root of 2 divided by square root of 2 is simply 1. So we're not actually changing the value of this. We're just changing what's on the denominator and what's on the numerator. So this is going to be negative 2 root 2 over 2. Okay, 2's are going to cancel out. And this is going to be equal to, your answer here is going to be equal to negative square root 2. And that's it, and you're done. Alright, so good luck with your homework, and hopefully this helps.